question number 1 from section 4.6, applications of exponential growth and decay functions. We have the following problems. Suppose that the amount in grams of polonium 210 present in a given sample is determined by the function defined by A of t equals 412 e to the negative 0.03 t, where t is the time in years. Find the amount present in a sample of 412 grams after 25 years. T is the number of years, and we're given 25 years. So we want to evaluate this 412 e to the negative 0.032 times 25. Notice I'm going to put extra parentheses around the entire exponent. You need a calculator to evaluate this. On a graphing calculator, you can locate the E button right over here, the second E, and then I'm going to put parentheses around negative 0.032 times 25. Okay, 412e to the negative 0.032 times 25 years. And we get 185.1235 grams. And I believe we want to round to the nearest whole gram. So this is going to be approximately 185 grams if you round it to the nearest whole gram. So this is an example of a decay function where it starts off as 412 grams, but over a period of 25 years, the 412 grams is reduced to 185 grams. It's an example of what we call exponential decay. Okay, let's look at number 2. Trish invests $5,000 in her IRA in a bond trust that pays 6% interest compounded quarterly. Sean invests $5,000 in his IRA in a certificate of deposit that pays 5.9% compounded continuously. Who has more money after 20 years? Well, they both put the same amount of money. The interest that Trish pays is 6%, slightly higher than Sean, but the way it's calculated is different. It's compounded quarterly. So for Trish, we're going to use the following A equals P times 1 plus R over N to the NT. For Trish, the principal is $5,000. P equals 5,000. The rate is 6%, R equals 0.06, change it to a decimal, and it's compounded quarterly, so N is equal to 4 times a year, and we want to see how much is there after 20 years, so T is equal to 20. So let's plug that into the formula. A equals P, that's 5,000, times 1 plus R, 0.06 divided by 4, all of it to the 4 times 20 power, N times T power. You need a calculator to evaluate this. Start off with your $5,000. 1 plus 0.06 divided by 4. And then you're going to raise that to a power 4 times 20. And I like to put the power in parentheses. So after 5 years, that $5,000 almost triples to, I'm sorry, after 20 years, that $5,000 almost triples to the amount, which is $16,453.31. Okay, now let's take a look at Sean. Sean invests the same amount of money, so P is equal to $5,000. The rate for Sean is 5.9% or 0.059. The T is 20 years, but it's compounded continuously, so we use this equation. our A is equal to 5,000 times e to the r 0.059 times 20 years. Put that in parentheses and evaluate. 5,000 times e raised to the power of 0.059 times 20 years. So Sean will end up earning interest, and that will grow, 5,000 will grow to $16,271.87. So, which has more by just a couple $100. Trish will have more money after 20 years. Okay, if we round this to the nearest cent, $16,453.31 for Trish, $16,271.87 for Sean, and then after 20 years, Trish is going to be the one with more money. All right, let's look at question number 3 from section 4.6. Find the doubling time of an investment earning 7% if interest is compounded continuously. Well, finding the doubling time. Now, the way you can do this, if you're trying to double your money and you start out with P dollars, P is the principal present value, then what you're going to do, you're going to end up with twice that, or 2P. So our accumulated amount, A, is going to equal twice what we started off with. A is equal to 2P. The interest that we're given, the rate, is equal to 7% as a decimal, 0.07. In this case, we're looking for the time. We're using the formula A equals P e to the RT. Our accumulated value, our future value for doubling our money is going to be 2P equals P e to the R, which is 0.07T. That is all the information that we're given. We can solve this equation for T, find the doubling time. We do that by simplifying this equation. Notice there's a P on the left and a P on the right. We're going to divide both sides by P, and we get the equation 2 equals e to the 0.07t. This is a exponential equation, and it has 3 parts. It has a base, has an exponent, and it has an argument. We're going to convert this to logarithmic form. So we can say log base e of 2 is equal to the exponent 0.07t. We have an equation that's in the form of b to the t equals r. We convert it to log base b of r equals t. That's our most common conversion equation that we're using in this chapter. So that's what we need to simplify this equation. Now, another way to write log base e of 2 is to write it as ln, the natural log of 2. That's the same thing as log base e of 2 equals 0.07t. We want to solve this for t by dividing both sides by 0.07. Those will divide out, and we get t by itself is the natural log of 2 divided by 0.07. Using a calculator, the natural log of 2, closing the parentheses, and then dividing by 0.07, we get 9.9 years. So we get t equals about 9.9 years. We'll round it to the nearest tenth of a year and check our answer. 9.9 years. So if you were looking to double your money and you found an investment that earns 7% interest compounded continuously, it would take almost 10 years to double your money.